Okay, for today, we're starting with the ambiguous case triangle, one of the toughest things that's on your next test. So, first off, we need you to be able to figure out that dotted blue line there, the height. And if that's going to make a right triangle, then a lot of kids think we should kick into the law of sines right here, and we do not. We instead go sine of 41 equals opposite, which is the height, which is across from the big A, so therefore it's little a. And it's little a over the hypotenuse, which is 12. And then you multiply both sides by 12. And 12 times the sine of 41 gives you 7 point, I have already forgotten. We already wrote that down, right? 7.87, thank you very much. So now, if that's 7.87, that would be the smallest it could be. So this right here, if that's 7.87, that leaves you one triangle. So let's assume for a moment that the height is 8. Well, if the answers are between 7.87 and this other side here of 12, those will give you the ambiguous case where you can't tell whether it's like the red line or the green line. But both of them are 8. That's 8 and that's 8. And you can't tell whether or not they would make the triangle by using the green line or make the triangle by using the red line. Okay, now I want you to figure out angle B1, and that'll in turn tell you B2. So everybody take a minute, figure out angle B1 and B2. Okay, so you should have set up the law of sines here, and the two side and angle combos that we know, or the one combo we know, is sine of 41 over 8 equals, and then the other angle I want here is, you're always going to end up getting B1 because of the way how inverse sine works. You'll always get an answer less than 90. So I'm going to go sine of B1 over 12, and then I'm timesing by 12 on both sides. And then this is a decimal. I'm going to pause while I get it. Okay, so this is 0.98. 98 what? 984, thank you. More accurate's better. There's going to be a lot of people that get problems marked wrong because they round too much. Don't round to the very end. I mean, you can round a little bit, but... And then I do inverse sine of that, and this one I will do myself. Inverse sine of 0.984. Did you get 79.7? All right, 79.7 is our B1. Notice how close that is to 80 degrees. Okay, it's really close to 80. Is it close to 90? Nope. So this is less than 90. So then there must be another one that's bigger than 90. So if this is 79.7 right here, 79.7 degrees, then this one's also 79.7 because it's a isosceles triangle. Look at the sides across from these angles are the same. So then the angles have to be the same. And then I take 180 minus that, and I get 100.26. Do you guys get how I got those? Any questions? All right. So, what could I ask you at that point? Oh, you've already got now, you've got angles all over the place, you've got sides all over the place, so I could ask you for any angle or any side. I'm going to ask you to figure out this, I'm going to make it a squiggly red side right there. On purpose, I picked one you don't have the side and you don't have the angle across from it. But you can get the angle across from it pretty easy. Find the squiggly red side. Pausing. Okay, squiggly red side. Well, we've already labeled one A and B, then this must be C up here. Okay, so that must be little c. Now, you don't have to name it that because we're not using the law of cosines. In the law of cosines, it matters what you call C. But here, I could have called it M or L, or doesn't really matter. But I'm going to start with that. And I'm going to go little c over sine of big C, but I need to know one of those. Oh yeah, I can know this angle right here. So I'm just going to take 180, and I think the fastest way is to go 180 minus the 41 and minus the, hold on, fumble fingers here, 180 minus 41 minus 100.26. And I get 38.74. And 38.74 up there. Means that this is 38.74. And then I use the pair I started with, which was the 41 and the 8. I had those from the beginning. So I'm going to use 8 over sine 41. Now, it's a multiplying by the sine of 38.74. Sine of 38.74 times 8. That's 5.006, and then divided by sine of 41. Anybody get 7.63? Okay, cool. 7.63. Any questions? I just basically multiplied that by sine of 38 to get C alone. Okay, so that is about as hard as they get. Now let's go into some like easy stuff. I'm surprised how many people get confused when it's just a right triangle. So here's a right triangle. This is R, this is F, and this is Q, and this is an angle symbol. I want to know what's that theta? Well, hint, you're going to use sine, cosine, or tangent, and you're going to probably use inverse of one of those two. So everybody start by doing sine, cosine, or tangent of theta, and then try to solve it down, and your answer will have R's or F's or Q's in it, and you'll probably have to inverse whatever function you picked. If you picked sine of theta as R over F, then you'd use inverse sine. All right, I'm going to pause for a second. Now, the bad thing about what I just did is that there's so many different ways you could answer it. I'm curious, how many of you actually used sine equals R over F? Raise your hand if you went that way. Okay, good. Did any of you use cosine of theta? 0 people? Okay. How about tangent of theta? Do you know that all of them would have worked? I'll just do cosine for a second. Cosine of theta would have been Q over F. And then all you have to do is inverse of that on both sides. Sorry, inverse sine goes up here. Inverse sine of R over F would be an answer. Or inverse cosine of Q over F. Okay, so your next question is going to use the law of, take a guess what I'm about to say. I was actually going to say sines. The reason I want to say law of sines is because it's the easier of the two. But it really only works in a certain situation. Would you please write down when will the law of sines work? And then I want you to compare your answer with the kid next to you. There's actually a few things you have to have. You have to have this, and you have to have this. When will the law of sines work? Okay, compare your answer with the kid next to you. Okay, if you said that it has to have an angle and the side across from it, that's a really good start because that is totally true. But do you get if I just give you an angle and a side across from it? You wouldn't have enough info. Like that can be 30 degrees and this side is 8 and you don't have enough info. Okay, so you need one more piece of info. Some people say you have to have 2 angles. False. You just have to have one more piece of info. It could be an extra side. It could be an extra angle. Okay. All right, so let's say it is 30 and 8. Do you think I could draw a triangle where that's 30 and the other one's 8? Sure. Now, telling you what the length of another side is here is very dangerous, because if I tell you that this is like 9.6, then I may just be wrong and the triangle doesn't exist. Okay, but telling you what one of the angles is, that's much safer. I can't say that this is 112 degrees up here. That's not safe. It's not going to work. But if I just look at it and say, what does that look like to you? That's pretty close to a right angle, isn't it? But if it was a right angle, you wouldn't be using the law of cosines or the law of sines, either one. So let's make it bigger than a right angle. Let's make it 95 degrees. Now, do you have enough info to figure out anything? Sure. Let's all use the law of sines to figure out this side right. Actually, I'm going to be mean, and I'm going to ask you to figure out this side right here. And let's give a name for that. I'm going to call this big C. And then let's just all use big A and big B. The reason is then you can compare your notes with the kid next to you, and they aren't all backwards, because if you pick different letters, you'd use different answers. But the question mark now is little c. Everybody figure out little c. And it doesn't just happen right away. Because if you go, okay, law of sines, he said law of sines would work. And then you go, well, but I don't have this angle. And I don't have this side, so I can't use those. But you do have that angle. You just don't realize it yet, maybe. Some of you probably realize it. All right. Take a second, set it up, solve it, and whoever's most accurate wins. It's going to happen. People are going to round early in the problem. They're going to get it wrong. Don't round till the very end. Okay, so I came up with 55 degrees for this right off the bat, which we need because we cannot afford to have C over sine of big C and try to keep going with the problem, because we don't have enough info. So we have to have 3 pieces of info, and that's one of them that we need. So we're going to use this 55 here, and I'm going to use the 8 over the sine 30. And I know this one in my head. Sine of 30 is a half. You're going to find out that's super handy to know in your head. 8 divided by a half is 16. So then I go, this is all 16 over here, because I knew sine of 30 is a half. Memorize it. It'll come in handy. Then I'm going to times by sine 55. And I'll just go over to my calculator here. 16 times sine of 55. As long as I'm not in radians or something. Oh my gosh, I'm in radians. Yep. Because I got a weird answer, I knew that I was in radians. I'll come back out and type in the same exact thing again. 16 times sine of 55. And this time, 13.1. Raise your hand if you had 13.1. Okay, good. All right. I had a negative answer. And that told me that something was messed up. But if I were you, I'd just make sure that your calculator is in degree mode right now, and then it'll probably still be in degree mode tomorrow. All right, that's law of sines. What do you think's left? Law of cosines. All right, so that can come in handy in multiple places. All right, if this is 2 and this is 5, if you had to guess, how long is the other side?
6.
Let's just think it through. Could it even be 3? Would that make any sense that that was 2 and 3, and then the other side is 5? Would that make any sense? If you laid them out like this, and this was 2, and then the other one was 3, that might help you see that there's no way that makes any sense. It can't be 2 and 3 and 5. Do you see what I mean? Because then it wouldn't even be open. Like there would be no space inside of it. So that side cannot be 3. Could it be 5? Well, it certainly wouldn't be drawn this way then. You know what I mean? If this was 2 and 5, then it would be an isosceles triangle, and it wouldn't look like that. Okay, so then how about 4? Does that seem possible? All right, so let's go with 4. 2, 4, 5 is not a right triangle. This is not supposed to be a right triangle. Okay, So now I can ask you to figure out this angle. It looks like it's about 90. Would you please figure out that angle? Now, in the law of cosines, this is the one time where it's super important which one is C. Allison, which one's got to be C then?
Which side?
Or at which angle, either way.
The angle across from B.
Yep. So this has got to be C, and then this must be little c. Perfect. You started right. Now, how about A and B? Well, let's just for the sake of being, like similar to each other, use A there and B there. Because otherwise, it's really hard to talk about the answer with the kid next to you. All right. So now, figure out angle C. We don't need little c. We already know that. It's 5. So figure out angle C using the law of cosines. I want to pause. Will you try that? Oh, wait. I'm going to actually give you more to do. Because once you find that angle, you can use it to find the area. And I will give you the formulas because we're going to give them to you on the test. This is the law of cosines. A squared plus B squared minus 2AB cosine of big C equals C squared. And then the other formula is area is 1/2. Does anybody have it memorized? Because it'll help you on the ACT if you do. ACT doesn't give it to you. 1/2 A. Can anybody do it from there? B. Sine C. Between the three of you guys. All right. AB sine and a big C. See, once you have that angle, it helps you to do this problem. There's another way to do it, though. And I'll explore that answer after we first found angle C with this formula. And then we use that angle to do this area triangle problem. Question? Okay, so I believe everything is going to work here, and I'd like you to find the area and angle C. I'll pause while you get that figured out. Okay, so I'm not going to do the whole thing because, man, these take forever to do. But basically, you would put in your A and B, which in this case are 2 and 4. So you're going to do 2 squared plus 4 squared minus 2 times 4 times cosine of big C equals C squared. And we know C. C is 5, so that's 25. And then you do a bunch of solving and you get down to cosine of C is equal to some decimal, and you do inverse cosine, and then you have your answer. Charlotte, what did you say C was? 108.21. And remember how I said it was close to 90, and that qualifies. It's kind of close to 90. And how many of you had 108.21 or something that would have rounded similarly? Okay, good. Remember that on the test, I'm throwing out this big, or if you would have round. Do you realize if you round early, you're likely to be off a lot at the end? Like I saw an example earlier today where it was rounded to the wrong spot just once, and the answer was off like 5 degrees at the end. That's a lot. You're going to get it wrong if you do that. Okay, so bottom line is just keep as long decimals in your answer till the end, and then you can round it. All right, and then if that's true, I can now do 1/2. The area is 1/2 AB, well, that's A. A is 2 times B is 4 times sine of 108. So then half of 2 is 1. 1 times 4 is 4. Sine of 108. So basically 4 times sine of 108.21. And I'm guessing that we've got people that have it. Henry, what did you guys get? You were gone, so I...
Yes.
All right. Graham, what did you guys get?
The area?
Yep.
3.799.
All right, now I'm going to think through what you just said, and I'm going to go, he says it's about 4. If this is close to a right triangle, base times height would have been 8, and then half of 8 is 4. And you're saying it's about 4. Does that pass the smell test on about, yeah, it's pretty close. As if this had been a right triangle, it would have been 4. And he's coming out with something a little less than 4, so that seems about right. Okay, raise your hand if you had an answer that would have rounded in the same neighborhood. Okay, good. Now, what if, weirdly, I had said, I'm not giving you 3 sides. I'm giving you 2 sides. Do I have and I haven't given you an angle either. If it's just this problem with 2 sides, have I given you enough info? No. But what if I told you the area? Do you get how you could reverse that and figure out what it would be? All right, you'd have to know that area formula or how to use it. All right. Once you figure out from the area what the other side is, then you got all the sides and you can use the law of cosines from there. So all I'm trying to say is I kept pounding that I got to tell you three things, but I don't necessarily have to tell you outright, here are the three sides. I can give you a way to find the other side. Okay, so for example, do you get that if I have three sides and there's 7, 8, and 9, do you remember that whole semi-perimeter thing? All right, I'm going to give you the formula for that and see if you can pull it off. This one has an area, right? We just don't know what it is. And I can't use base times height. I don't know the height. So how about, could I use law of cosines to figure out an angle? Sure, but that's really long and painful. So instead, here is the right formula. Square root of, well, if I should put area equals in front. Always start with both sides of the formula. You got to start with A equals. And I'll give it to you because we will on the test too. I feel like we're wimping out. It's an honors class. You can memorize a formula, but overruled. That is your formula. Now, can you use it to find the area for me? If you forgot what semi-perimeter is, it's the perimeter, but cut in half. So that S in the formula, it's the perimeter, but cut in half. Semi means half of. All right, I'll pause while you figure out the area. Okay, I am sensing a lot of you are already done. It adds up to 24. Half of that is 12. So 12, 12, 12, and 12. Please stop me if I'm wrong. Is that am I right so far? Okay, good. Then I'm going to subtract 7 and 8 and 9. So then this is square root of 12. 12 minus 7 is 5, 4, and 3. And 9, or 5 times 4 is 20, times 3 is 60, times 12. I'm wimping out because I happen to have it right here. And that is 720. Square root of 720. Second square root, 720 is 26.8. Now, does that pass the smell test? I would always do this just in my head quick and go, well, sometimes it's 56. Half of 56, and they're saying it's 26. Okay. And this is close to a right angle. It's not a right angle, otherwise I would have done that. But that kind of passes the smell test. That's about right. And I have a little degree symbol I got to get out of there because that is not degrees. That is an area. Okay. So, yeah, that kind of makes sense to me. Okay. I think you have enough info now. So I would strongly recommend that you start on your homework. This is assigned. It is going in the grade book. It is a Schoology quiz. You got 2 chances on it. After the first try, you get the answers. So you get guaranteed on your second try, you're going to get 100%. But don't just put in crap on the first try because you're getting the average of your 2. So try. And then also, if you struggle with one of them, make sure that, like when you see the answer, that you take the time to go back and figure out how you can get that answer. Okay, so Schoology quiz is assigned. There's another folder in there that basically gives you another review. It's on paper. It's more of a PDF, you know. I would only use that if we get school called off tomorrow and you're like, okay, I've forgotten what we're testing on even. Then use that. Use the Schoology quiz as your top priority. Of course, if you want more things to study, you can always do it. The one that's on the PDF. All right, and that's all I have for you for the video for today.